say kudos to them all. So picking it up from where Alex left off, I'll be speaking on Python algorithms for data science job interviews. And then my name is Gilbert J. I work as a senior data scientist at Float, and I lead the data science team. Previously, I used to work at Superfluid Labs, where I worked as a data science engineer. I have a vast number of years of experience in the data science field, and it's a pleasure to share knowledge with you with regards to algorithms, data science algorithms, and Python algorithms to help you polish certain things up when it comes to interviews. So what Float does is we give out credit to SMEs. So what I basically do is I apply the data science to the internal data plus external data that we have to ensure that we give out the right loans to the right customers. And you can check it up later when you are free, what we do at Float. Today's content will be about the platforms that you can use to prepare when it comes to job interviews. I believe that the previous speakers did a wonderful job and speaking about how to introduce yourself in interviews. The second speaker spoke about the various tips, and Walla also spoke about the various data structures that one needs to know when it comes to the data science field and Python in general. So there are numerous platforms, but I'll point out to you guys the ones that really stand out and the top questions asked by the FANG. So right now, Facebook is calling themselves Meta. So Facebook, Google, Amazon, and Microsoft, etc., etc. So you can see that there is something called, there's a correlation in all the algorithms that these companies ask. So the whole concept is that they want to test your thinking ability and then your problem solving skills. Algorithm basically is the step-by-step to solve a problem. That is what an algorithm is. So they just want to see your steps, the step-by-step way in which you are going to solve a problem. And we'll look out for the learning resources. And then finally, I'll conclude on this section and also give some tips. Now, talking about the platforms you can use to prepare when it comes to algorithms, you have numerous of them. You have tons and tons of them. But my personal preference is the one that I use a lot is HackerRank, and then I also use LeetCode sometimes. But these are all very good platforms. They are very excellent platforms you can use to prepare for algorithms. And the good thing about it is it's not limited to only one language. We have tons of languages over there. So software engineers can prepare, QA engineers can prepare, system administrators, data scientists, machine learning. People use different tools for different things, and the platforms really support a lot of these languages. Now, since we are in the data space, people make a lot of comparisons with Python and R, which I don't see it to be very relevant because you can use R for anything, and then you can equally use Python for anything. So the good thing about it is knowing the right tool to use at the right time. I prefer to use Python because of its advantages, but I think that it's really needless when people make R versus Python comparison. So for this purpose, for this tutorial or for this web presentation, I'll be talking more about Python. Python, not only can you use it in data science, but you can use it in other things as well. So it is gradually becoming the de facto language when it comes to data science. Now, let's look at some of the most asked algorithms asked by the top companies that we know worldwide. This is not limited to only Facebook, Google, Amazon, and Microsoft. Personally, my personal experience, it wasn't more like an algorithm question per se, but for all the companies that I've interviewed with and then worked with, when I had my interview, of course, you had to go through the very first step, how to introduce yourself, how to speak about yourself, and then also the second speaker talking about the tips, and then I was also tested on data structures and algorithms, but it wasn't the raw data structures and algorithms. It was part of a whole. So it wasn't like define what a linked list is or define what a certain, let's say, minimum heap is or define what a tuple is. It was more like framed in a question where you are going to apply all these concepts. So it is good to know them, but knowing them isn't enough unless you use it to solve a problem. So yes, you can memorize the definition of all these data structures and algorithms, but if you don't put it into practice, then it doesn't really speak well of you. So the very first algorithm that we are going to look out for is the linear search. And that is the simplest or the easiest method of searching a data set. Since we are in the data space, definitely you are going to look out for something matching something in your data set. And the easiest way is to do a linear search. So how it operates is you start at the beginning of the data set, and then so you start from the very left, and then you go through each item. So you go through the item until what you are looking for is matched. So once that item is found, then the search ends. So let me quickly show you how we can implement a linear search. Then for the rest, since we have 10 minutes, I'll speak through it and then let you understand it. And there are resources for you to also search and then learn on your own. Now, how do we implement a linear search? So like I mentioned, I'm going to use Python. So in Python, once you do this, it means you are creating a function. And let's say you are looking out for an array and then an index. So takes in an array and an index. And from the explanation of the linear search, you go through the leftmost part of the array right through to the end, searching for a particular thing. And once the search is found, then the search ends. So go for index in range len of array if, let me see, if array of let me name this search item is equal to the search item, then we return the index position of it. If not, then you return -1. So this is the implementation of the linear search. Now, if we want to test for it, let's say we define an array and then call it, I think it's 10 million, right? So let's say 10 in, well, for, let me just leave it as 10 in, and then.
Well, it's 10 million. Or you intend to store it as 10 million, or you want to leave it in 10?
Yes, I want to leave it in. It's quite long for me to type.
Okay, don't worry.
All right, so yeah, we'll call it, and then you pass the array. And then let's say we are searching for R. So the index position for R is 2. So this is how the linear search algorithm is implemented in Python. It's one of the easiest way to search your data set. Now, we have the bubble sort too. Now, this concept is also very important to know. In fact, all the sorting algorithms are very important to know, but it's great to know when to use which sorting algorithm. Fortunately, in Python, it uses the efficient sorting algorithm. And speaking about efficiency, you also need to understand time complexity. So for the algorithm that I wrote over here, the time complexity of this is O of n. So when I say time complexity, as you are writing your code, you are going through the data sets and all that. You want to avoid delay in terms of time, and then you also want to use or optimize the resources that you have. So let's say if you are using a 4 GB RAM or 8 GB RAM or 16, you want to ensure that the code that you run is optimized enough so that your machine will not break. And then also for the big companies, just imagine Google or Amazon or any other company, the number of data sets that they collect on us. Then as we are doing everything, going about our day-to-day activity, they have tons of data on us. So if you are programming or if you are doing anything, you have to use the optimized way. So any algorithm or any code that you write has to be optimized. And you should be shooting for O of 1. And that is what we call the time complexity. You can read about it. I've left some notes in the slide. So this, if you evaluate this particular algorithm, it runs for O of n. It's a linear search. So it is O of n in the sense that it grows with the input data that you have. So yeah, coming to bubble sort, it's how it works is it's repeated, it swaps adjacent elements if they are in the wrong order. So looking out for something like this example, TEMIN. Let's say if you want to use the bubble sort for E, you want to ensure that you are doing a bubble sort, but you compare T and E, which one is supposed to come first. Obviously, E comes before T in terms of alphabetical order. So you compare the adjacent elements and then you swap them. Then you compare the adjacent elements, which one should come first, you swap them. So that's how the bubble sort also operates. Now, like I mentioned earlier, Python uses the optimized way when it comes to sorting. Fortunately, there's a method called .sort, and then the time complexity for that one is O of n log n. So it's pretty much better than the sorting algorithms, other sorting algorithms. The other sorting algorithms have a time complexity of O of n squared, which is very bad. So it's one of the reasons why people prefer Python over R. So Python is really good when it comes to data structures and algorithms and, building scalable systems. So not to tarnish R, but Python is gradually winning. When it comes to anagram, we say strings are anagram, or they are said to be anagram if you can form a string by arranging the characters of another string, right? So looking at race and care, definitely if you swap elements, you can modify race. You can just bring C here and then R here, and then that will be a care, and that will be said to be an anagram. So it's something that you can keep in mind too. The other search is the binary search. Sorry about that. The binary search. So the binary search is an algorithm that finds a particular element in the list. And how that one also works is if we have a list of 1,000 elements and you want to get the index position of an element, we just use the binary search, right? So that one too is very, very, very common. And that one too, fortunately, you can implement it yourself in Python, but we have methods to do that already. Then the final sorting algorithm that we'll be talking about today is the quicksort. So the quicksort, how it works is you can have a very big array, but how the quicksort is implemented is it's partitions or it groups. It breaks the big array into smaller chunks of array and then performs the sorting on the smaller chunks. So that is its methodology if you want to do the quicksort. And like I mentioned earlier, we have many sorting algorithms. But if you are doing Python, you are using Python, you don't have to implement each of these sorting algorithms yourself. We have a method in Python to just sort it for you in a more optimized manner. But it's good to know the concept, since during the interview session, you can be asked to implement it yourself. I believe this has been a very great session. If there are any questions, please let me know. And it's great speaking to you. Thank you.